everyone, this is Annie here from the University of Kansas Geology 105 online lecture, and today I'm going to talk about the Devonian age, or the Devonian period in the history of the Earth. Before this assignment, I didn't know much about the specific periods that Earth's history is divided into, but learning about the Devonian period has been quite interesting for me, as well as learning about other time periods from assignments. So I'm very excited to share that information with you. I will first give you all a basic background on the period itself, and then further discuss the life, the climate, and the tectonics of the time. So let's begin by jumping into the period itself. The Devonian period occurred about 416 to 359 million years ago. It was preceded by the Silurian period and followed by the Carboniferous period. I was wondering where the name Devonian came from, and I came across an article from National Geographic that mentions that the origin of the name Devonian is because of a specific place, Devon, England, and the reason why the period is named after this place is because a lot of the major studies and findings are connected to Devon, England. So a lot of research has been done there. So now let's start by talking about some of the life that was present. The University of California Museum of Paleontology gives a great overview of the Devonian time period, including the plants and animals that dominated the time. There's great evidence surrounding the presence of plants during the Devonian age, including evidence to support the presence of vascular plants that were present and ever-growing. The Rhynie Chert is a great example of how we have obtained this information. The Rhynie Chert is a natural area, some could call it a fossil bed, found in Scotland that has presented geologists with a number of fossils and great knowledge on the Devonian time period. The museum goes on to discuss that the reason why we have these fossils is because at some point a lot of sediment covered the top of the fossils, and through that and other processes that took place on Earth, it created almost a seal that protected and preserved the fossils, and furthermore has allowed us to learn about the time period from them. The museum also points out that there were other plants present besides vascular plants, such as algae and fungi, and in addition, the Smithsonian National Museum of Natural History highlights that the Devonian period saw the birth of major trees and forests. Evidence suggests that this kind of environment was developed towards the end of the Devonian age. And I also want to point out that because vascular plants were so present during this time and made so many advancements, trees were able to survive and thrive on the earth because of the advanced root systems that evolved based on vascular plants. This especially helped in the dry climate, which we will discuss later. And now I want to look at some of the other organisms that were present during the time. The University of California Museum of Paleontology also discusses that it was a great time for animals and other organisms, such as tetrapods and arthropods. Tetrapods were organisms that lived on land, but also had some features that allowed them to be in water, very versatile features. And arthropods can be thought of, according to the website, as wingless insects and were present during this time. Besides life on land and, insects and whatnot, life in the ocean was booming during this period. Brachiopods were ever present, as well as cephalopods. Many of these aquatic species are credited with the formation of reefs and a lot of reef systems. The Devonian period is a lot of times called the Age of Fishes because of all the species that came out of it and the evolution of them and just how much life was really collected in our oceans. The Smithsonian National Museum of Natural History goes on to mention that there was a major extinction during the Devonian period, most likely towards the end of the time span. Statistics from the website report that about 70% of the invertebrates were no longer around at the time of the extinction. That is a lot of species that, were affected by this extinction. The organisms in bodies of water definitely outnumbered other species as far as becoming extinct. And there have been difficulties pointing out what exactly caused the extinction, but there have been a few guesses and ideas that try to explain why this happened. One of the explanations suggests that because plants, vascular plants, trees, forests, were taking over the earth, really, the land on earth, that a lot of the carbon dioxide was becoming depleted. And, the species needed the carbon dioxide to survive. And in addition to that, the earth may have experienced at some point some sort of cooling, and glaciers might have been present somewhere on the earth. Besides that, on top of that, there have been some theories about an asteroid hitting the earth somewhere and that affecting the species, the extinction. And so there's a lot of explanations out there for it, and unfortunately, one explanation has been pinned down as this is what happened, but these are some great guesses that really make sense as to why these species became extinct. Now let's move on to the climate and tectonics of the time. The climate, according to the Smithsonian National Museum of Natural History, was rather dry and had fairly warm temperatures. As I previously mentioned, a change in the global temperature might have been the reason behind the extinction of species, and the University of California Museum of Paleontology discusses that because organisms in the ocean were so greatly affected by the extinction, that along with cooling temperatures and glaciers, there's a lot of reason to believe that sea levels may have experienced a dramatic decrease, and that makes sense as to why the organisms living in water were so greatly affected. Now that we know a little bit about the climate, I want to move on to the tectonics of the time. As we've learned in previous lectures, tectonics can really tell us a lot about the Earth. The Devonian period had a lot of tectonic activity and a lot of recognizable results from that tectonic activity. The Devonian period's land masses were part of two very larger masses, or supercontinents. These continents were called Gondwana and Euramerica. The University of California Museum of Paleontology tells us that while the continents took up a large amount of space and they were rather large, that the ocean was really the dominant space in Earth. The museum also points out that there were many areas of subduction surrounding these two continents. As we know from previous lectures and units, subduction is really a lot of times a result of a convergent boundary between plates, and subduction is really the result of that boundary. So the convergent boundaries and the subduction that was surrounding these continents, these were the perfect invitations for the formation of one large landmass. And the result of these two continents that were moving together and converged was the supercontinent Pangaea. This major event was accompanied by another tectonic event, which formed the Appalachian Mountains, and this occurred when North America and Europe collided. And in addition to these tectonic activities, the formation of Pangaea and the formation of Appalachian Mountains, I also mentioned the importance of reefs during this period. The significance of tectonic plates and reefs in this case is the fact that a lot of the reefs were built in spaces of the sea between continents that separated the continents from one another. So that's how tectonic plates kind of plays a role in the formation of reefs. So a lot of what we know about this time period is because of fossils and other landforms. Like I mentioned before, the Rhynie Chert is a great example of how we know this information about the time period. The Rhynie Chert is an area that's full of fossils from the Devonian period and has allowed scientists and geologists to really study and learn about the specifics of the period, including life and climate and even tectonic plates. Another example is something like the Appalachian Mountains. The Appalachian Mountains are a visible feature of our Earth that is evidence of some sort of collision between two landmasses. And as I mentioned before, that when North America and Europe collided, the Appalachian Mountains formed. And so the University of California Museum of Paleontology really emphasizes that in their section about plate tectonics. And I think that's really interesting because it is a concrete form of evidence that allows us to learn about how the tectonics of the time were operating. The Earth and its structures can tell us a great deal about the past, and that is something that I find very fascinating. It is amazing to think about all that happened during the Devonian time period. There were new species, the growth of plants like vascular plants, trees, and forests. There was evolution of organisms, but moreover, there was extinction of a lot of the life that covered Earth. One event that really interested me was the formation of Pangea and the impact it had on the future time periods of the Earth. I imagine that without this event, our Earth would look quite different today than it would have without this. Without that, our Earth might look very different, like I said, and it just goes to show that all the events that have occurred in our history are relevant to now and can help us learn about the past. I really enjoy learning about the life, the climate, tectonics, and the reason why all these findings have come about with regards to this specific time period. And I hope all of you enjoyed it as well. Thank you!